That was such a good introduction. Now I don't have to. But now I'm like Oprah. Okay, there we go. Kind of like that. Okay, so here's what. I got a bunch of stuff written all over here. Let's talk about what standard form means. Standard form means this. It's got 3 parts to it. Number 1, X and Y on the same side. Do you have to write that down? You don't. I'm just doing it for the kids at home, right? X and Y on the same side and it equals a number, right? So X and Y on the same side equals a number. That's the first thing. Second thing, it's got to have no fractional coefficients. And you're like, what the hell does that mean? That means this. No fractions in front of X and Y, right? We want them to be whole numbers. And if they're not, we make it that way. And the final thing that's kind of weird is we want X in front and positive, right? We don't want them to be negative. Here's why. We're going to do systems of equations in 2 chapters. Remember when you that adding and subtracting method and you line everything up? Well, that's why you want it all very fancy. You want X's to line up, Y's to line up, equals to line up, numbers to line up. So let's try let's remember how the hell to get things into our friend standard form. Let's see, I got that. That's a scary one. Okay, let's start with this dude right here. So if you got your little whiteboard pen out, here we go. That guy almost looks like he's in standard form. He's damn close. X's and Y's are on the same side. Yay. Equals a number. Yay. No fractions in the very beginning. Yay and yay. But I don't like that guy. I don't want him to be negative. So what someone told me last period is like, can you just flip-flop him? We can't. The X needs to be in the front. So I need to change this guy's sign. Does anyone know what I can do when there's an equal sign that I can? It's kind of an easy trick to change this guy's sign. Anyone have a guess? It's easier than you think. Guess what I'm going to do? I am going to change his sign. Boom. But if I change his, I got to change everybody's. So this guy now becomes negative, and this guy becomes positive. Awesome. Awesome. You know what we just did? We multiplied by -1. That's the real thing, right? So here's what I remember. If I change one, I change them all. That's how math is. It's equal, right? If you're going to mess with this guy, that's cool. Just change him. You just can't randomly be like, you're positive now. It's like, okay, fine. It's like you're turning them inside out. And that's totally cool. You change one, change them all. We're times these by -1. Yeah, nice and easy. Okay. Let's step up our game a little bit here. That's pretty easy. Let's go to something a little bit trickier than that. What about this guy? I want him in standard form. I need to get X's and Y's on the same side. So can we move that X around? Sure. And do that. And then you might have the wrong sign. So fix that too, right? Give it a shot. You got this. You're going to do it on your whiteboard desk. When you have an answer you like, peek over at your neighbors. See if they're as smart as you. If they're not, mock it. That's Hey, so here's what I'm going to do. I don't like this guy. I'm going to move him over. Boom. So I got -2x plus y equals -9. But we remember from the last problem, I need that guy positive. So change. I'm good to go. It's nice and easy. Don't let it freak you out. Super easy. The next one is one of my favorites, and I feel like a lot of kids don't remember this next one. So we're going to talk about this bad boy. He is one of my favorites. Ooh, scary. Yeah, bad. I'm going to tell you this. This is one of my favorite things to do in all of math. And I get to do it whenever there's an equal sign. I do not like fractions very much. I really don't. So I want to get rid of them. I want to get rid of those fractions. So here's what I know that's happening. First thing is, I want to make everyone a fraction. He's a fraction, they're all fractions. So what I'm going to do is this, kind of like I could change everyone's sign. I'm going to do that exact same thing. I'm going to multiply everything by a magical number. And that magical number is a number that would get rid of 4, get rid of 3, and get rid of 1. What is the number that 4 and 3 and 1 go into? Goes into 12. You got it. So watch what I'm going to do. I'm going to give him a 12. I'm going to give him a 12. And I'm going to get him a 12. And like I'd like you to do right now, see if you remember to do a little bit of canceling and see what you're left with. I'm going to do it in a minute, but let's see if you kind of remember what to do at this point, right? We're going to go do a little of this action. 4 goes into 4 once. 4 goes into this 3 times. Okay? You kind of remember how to do that? Beautiful. You're on the right track, right? Keep on going. And don't forget that last guy gets a 12. That is the most common mistake. Everyone's like, ooh, the 4 gets it and the 3 gets it. So does the last guy. Everyone gets it. Fair is fair, right? So here's what we're going to do. 4 goes into 12 3 times. 3 times 3, we're going to get 9x. 3 goes into 12 4 times. 4 times negative 1 is negative 4y. And that just is 12. See how pretty she is now? That looks way less scary. The other one was like, oh, fractions, I don't want to do it. But that, walk in the park. That's easy. You can do that. Yeah. Okay. How about this next one? I'm going to tell the truth on this next one. Oh, the one, oh, wait, hold on a second. La, la, la. This is a thing called a point slope form. And I'd like you to get that into standard form. But I gotta be really honest, there was a time like in the early 2000s where they tried to make that form a thing. And it just didn't stick. Like, I haven't learned it. No, next one. Can you get that into standard form? Can you put that in standard form? But we did. We tried to make point slope a thing, and it just didn't. It didn't work. Is your pen bent? I can have it. Throw it away. Yeah, we took them from last summer, so we didn't. If you're like, Ms. T, this is light work, it should be 3x minus 21. I'm going to move the 3x over. Ooh. And I'm going to move the 5 over. And then I'm going to change it all, do my little changey. How'd you do? Did yours look like mine? You okay? You feeling it? Yeah. I got one last one to do, and I'm going to be honest. I'm going to take this from a student who is in calculus this year. She's a really smart girl, but she got a problem, and she was a little freaked by it. Oh no, I'm not going to do it. I'll do it. I'll do that one later. Sorry. So that's standard form. Yay. The more common form that y'all know that we love so much is this form. Y equals mx plus b, right? We love that boy. That's called slope-intercept, right? This is our slope. This is our intercept point. That's where it crosses the y-axis. Here's a couple things you got to know on this one. You got to get y by itself. And I'm telling you, the key is this x guy needs to be right next to this guy, right? And that messes some kids up. So this is the more common way that we take standard form and rewrite it like this because we like graphing from this bad boy. So we're going to try we're just going to try 2 of these. I'm not even going to do this one. I don't even care. Could you put that guy in slope intercept or y-intercept form? You've done this literally for 3 years. So we're not going to do a ton of these. You guys should be okay with it. Here's our goal. Just a quick refresher. I want to get this guy alone. I'm going to give you a little hint though, my little lambs. Oh, put that negative next to the 2. You don't know how many kids move that 3x over and that negative in front of the 2 just literally goes away. It just disappears. It's trapped next to the 2. Yeah. And then remember what we want to do when we move this guy over. We want to shove him right up in there, right? It's like we're going to ask that x just scooch over. Divide by -2, divide by -2, divide by -2. Y equals, careful, negative and negative is a positive. If you got that, you're a professional. Could I see a wiggle of fingers of my friends who said I got that and it was right work for them? Okay, well, nice, nice, nice. I'm going to show you one. This is the Mia problem. Lovely girl. Like, she's a super sweetheart. And she had to graph this, and she's all, Miss T, why am I forgetting how to do this? Did you do me a favor? Like, could you put that into y-intercept form? Like, what would you do if you saw that and someone said graph that? Like, what would you do? Here's a hint. Get rid of the f of x. Yeah, you're on the right track. But get rid of that f of x. Rewrite it as what? Y. Sure. Yes, I'm writing what you're telling me. Here's what she remembered. Boom. That's super easy to graph. But that is like, what? I don't remember what to do there. Yeah. Put the x's first. Number second. Okay. So that's writing equations. That was literally what we spent like 3 days doing in Algebra 1 and a day in Algebra 2. That was 10 minutes. Here comes graphing equations. Did you actually know there are 5 ways to graph almost any equation? And we're going to talk about those 5 ways. We really care about 2 of them today. One of them we're going to talk about tomorrow. But the first way is table of values. I'm going to be honest, it's my least favorite, and we're not going to do it that much in here because kids make mistakes. No, that's not true. Adults, everyone makes mistakes. I don't know how many kids, like they're doing everything right, and then they make their table of values, and they're like 5,1, and then it's supposed to be 3, it's supposed to be -7, but that negative kind of, they write it funny so it looks like that, and then they just graph 3,7, and then they have the whole wrong answer, right? So I'm not a huge fan of this except for one time. If you're desperate, if you're taking a quiz or a test and you're like, holy crap, I forgot how to do this, you can always make a table of graphs. If you're going to be smart, are you going to plug in a number like 17? No, 17 is a dumb number to plug in. Please be smart. Plug in nice numbers. 0 is often a nice number. 2 is often a nice number. You always want to throw in a negative just to see what's happening. But pick smart numbers. If you are going to do a table of values, don't be an idiot. I'll walk by and I'm like, why? Why did you plug in 5? It's like, I don't know. It's like, don't plug in 5. Okay. But we don't love this method. We don't love this method. I'm going to scroll to the back and tell you the other method that we're going to talk about later. Graphing technology, graphing calculators. I'm not, and I think I've said this before, not a giant fan of the graphic calculator because I think there's an equity issue there. Some kids can afford it and some kids aren't. We will do some technology graphing here. We're going to do them on our Chromebook because a Desmos calculator is a way better calculator to graph on than your graphing calculator. Can you use a graphing calculator in here day to day? Yes, but often on tests, I'm going to say you got to use one of mine, right? So if you had Algebra 2 trig last year and you did a lot of your graphing on a graphing calculator, and it's like, we were allowed to use those on a test. Yeah, not so much for me, okay? But sometimes that's what we're going to do because it's an easier way to do it, right? The second way is intercepts. We're going to talk about that tomorrow. But the big two, here we are. One is this guy. It's the basic one, which is if I have let me move this. If I have a starting point, and if I know the direction I'm going, I am good to graph anything, right? If you give me this as a starting point, 3, 2, and you give me this as my slope, which is direction, 1/2, I can graph anything, right? I'm just going to go over to 3, 2. I'm going to go up 1/2. I am good to go. All I need is 2 bits of information, a starting point and a slope, a direction. That's all I need. So what we're going to do is practice that. You guys know how to do this. This is light work right here. So let's see if you guys can remember. Let me find a good one that's all kind of, how about this? How about we start with this bad boy? Graph that guy, please. Nice and easy on your little graphy thing. This should be light work. Right here, you should be like, right? Remember, this guy is our starting point on the y-axis. 3. This is our up. This is our across. Nice and easy. Your teachers might have said rise over run. I hate those words. Up and across. Why? Why rise, why run? That was a rise. No one knows what that means. It's up on top, it's across on bottom. And you have a little cute graph. Look at your neighbors. Again, make sure yours is better and mock them if theirs is wrong. Boom, right here. I'm going to go up 1. I'm going to over 2. I always do at least 3 points because it's prettier. Up 1 over 2. Boom. Shoot. Look at her. She's beautiful. She's beautiful. Okay, so I'm going to tell you something else now. This is a Mrs. Tarantino trick. You do you. I have a lot of kids who mess this up. Here we go. So I have so many kids who think, oh, that means we go down and it means we go toward the door. And that's negative. So I'm going to tell you how I graph. And if it messes you up, then don't ask me. Just be like, I'm good, Miss T, don't help me. I always put my negative down here. Let me show you why. I'm going to start at 3. I, personally, after 30 freaking years of doing this, I always go up. And then I decide if it's negative, I go this way. And if it's positive, I go that way. It's easier for me to do it that way than to try to switch it around. Do I go up sometimes? Do I go down sometimes? I always go up. And then if it's positive, boom. If it's negative, boom. That works for me. So if you are finding you are missing these because you're going the wrong direction, give that a try. You guys cool? Okay, here's another one for you to try. Let me move this around. I made such a mess with all these. Let's see a nice one. No, not that one. No, oh, not that one. How about this one? Ooh, there, that's an easy one. Can you graph that one? Holy guacamole, I got no slope. But I do have a slope. There's just a hidden number in front. What number is hiding in the front? 1. And if I want to make that a fraction, 1 over 1. There you go. And listen to you saying it. 1 over 1. Just be careful going the negative direction. Nice and easy. Boom. Up 1 over 1. Up 1 over 1. Pretty. Okay. Here's the real deal. That's all baby math. This is the real thing. Graph that bad boy. Guess what? He's not in a form we like. He's not y equals. I don't know where his starting point is. I don't know where his slope is. So change him, Colton, into y equals. Look, I only know 3 names. That was so handy. Change it into y equals. Again, light work, algebra 1, algebra 2. Watch your negative and positives, my sweet potatoes. Oh. How did I do? Did I do okay?
Yeah, you did great.
Thank you. I appreciate that. You're not letting me do the whole problem wrong. 1, 2, 3, 4. 1, 2, 3. Boom. 1, 2, 3, 4. 1, 2, 3. Boom. How do you look? Yeah? Are we good? Are we looking good? Let's look at your little graph. So pretty. I'm going to jump ahead. We're going to go to the last. Oh, I don't even care about that one. We're going to go to we're going to do that tomorrow. Last one are the weirdo ones. You ready? There are 3 weirdo ones. And you just got to watch for them. And I'm going to show them to you. And they look kind of the same, but they're not. So the 3 weirdo ones are right here. Here come my weirdo ones. I'm not even going to do that. It is this one. Y equals X. Y equals 3. And X equals 3. These are the weirdo ones. And I catch people with these every single year. And I'm going to give you some hints on them. So the first one right here, the Y equals X, is not truly a weirdo problem. It's actually a really easy problem. It's got an X and a Y. It's a regular old slanty line. It's just super easy to graph. So do me a favor, please, on your paper, on your whiteboard, graph this baby. Don't let it fool you. It's not a trick problem. It's just so easy we miss it. So go ahead and graph this. You're graphing this one. Guys, you're graphing that. And it should be so easy, yeah? Up 1 over 1. But it's not a trick problem. The next 2 are trick problems, but not this one. And if you went, hey, Miss T, it's just this, then I'd be like, you are awesome. You are awesome, yeah? But let's talk about these next 2. And here's my issue. My issue is after doing this a bazillion years, I get the next 2 wrong. I used to get them wrong all the time. They are missing a letter. They don't have an X and a Y. They only have 1. So that means they are the weirdo ones that are either going to be straight up and down or side to side. And if you're like me, I never can remember which is which. So I have a trick to doing it. Are you ready? I call them the Mrs. Tarantino heartbreak problems. And this has worked for me. You do you. You see if you like this. So I'm going to graph this guy, and I'm never going to get it wrong. And here's what I do. I say to myself, oh, that's a heartbreak problem because it's missing a letter. So I go to the Y line. I go to 3. There it is. I put a little baby heart on 3. I swear to God, I do this. And then I break the heart. And I graph it. And I never get it wrong, right? Heartbreak problem. So if I'm going to graph X equals 3, guess what I'm going to do? I'm going to go to the X line. I'm going to go to the 3. I'm going to put a heart there. I'm going to graph it. I've just graphed it, right? Every time you'll get it right. Kind of got to memorize it. But the heartbreak works for me. Does that work for you guys? We good? Yeah? Everybody good? That's it for today. I'm going to show you what we're doing. I'm going to give you your homework. I'm going to take some problems off. Don't dive into it. I'll give you your quizzes back after that. Goodbye to anyone who was light work.